Cathode and April. And that's all. Okay, so today is the second part of the lab we will do from last week. And last week we did the first part, and we're making the benzoic acid through the linear reactions. And today we're going to work up reactions. So last week we were making this from the bromide bromobenzene using the mechanism turnings and making this reagent. And this reagent is really reactive toward ice, like dry ice, the carbon dioxide. So remember, you put the dry ice in the first beaker, which is containing the Grignard reagent. So when you put the dry ice inside, you're making this compound. So this compound is rather sitting in the storm. So that's a compound we made 2 weeks ago. You put the dry ice inside, and the Grignard reaction will react with carbon dioxide and making that compound. Okay. So now today, the first step we're going to work out the reaction to purify a compound, to isolate the compound to function of the impurities. So first step we're going to add going here. So we're going to add hydrochloric acid. So how much of hydrochloric acid you can add into the flask? Can we go to the left menu? 7.5 liters of the hydrochloric acid together with some ice. So you can just add the random amount of ice into the beaker and also add the hydrochloric acid inside. So why do you need to add hydrochloric acid inside? To do what? What's that mean? Why do you need the hydrochloric acid to the hydrochloric acid? So go back to the equation. You're using hydrochloric acid, it's acid solutions to make the benzoic acid, correct? Okay, that first step also need to add some diethyl ether inside. Diethyl ether is a non-polar solvent. Okay, so now you imagine you have a diethyl ether and you also have a hydrochloric acid solutions. And you are from 2 layers, right? So which component is going to the top layer, which component to the bottom layer? That's the one thing you need to ask yourself first. So under this acidic condition, like pH acidic, lower than pH 7. And you're going to add the acid and diethyl ether inside, and which layer containing your product? Top one. Okay. So the top one contains your product, but also you also have some side products. So what is the major side product you may have in these reactions? So imagine the first step you're making the Grignard reaction, right? The Grignard compound. This Grignard compound is really reactive towards water and towards itself. So what is the major side product you may have in this product? So for them, because this guy can also react with moisture, water, so this guy can react with water and give you benzene. And my question is that is benzene non-polar or polar solid? Polar. Benzene is polar or non-polar? So benzene, polar? Non-polar. So if benzene is non-polar, when you have diethyl ether and also you have water, does benzene go to the top or does benzene go to the bottom layer? Top layer. Bottom or top? So benzene is non-polar, so just where does it go? So what is on top of layer? Is it ether or aqueous layer? Ether, so big white. So why the ether is on top and the aqueous layer on bottom? So one thing that you have to remember the knowledge you learned from the acid-base reactions. That because of the ether is less dense than water. The density of water is 1 gram per milliliter, but the density of diethyl ether is roughly around 0.9. So because the ether is less denser than water, so ether on top and aqueous on the bottom. So by doing this, you can extract a compound, non-polar compound into the diethyl ether phase, which is on top. Right. But benzene, is benzene polar, right, or non-polar? Is benzene polar or non-polar? Non-polar, so where does benzene go if you have 2 phases? Top layer, right? So on top layer right now, you have benzene, which is a major side product, and then you also have the benzoic acid, which is your product. And how can you separate the benzoic acid from the benzene?
Washing it with water and extracting it with NaOH.
Regular water won't do that. You you need some other water. You need a strong water. If the water good, but you also change the pH of the water. So if your water is acidic, you will only make the benzoic acid go to the diethyl ether layer. So you are making the benzoic acid. So imagine you have right now this guy is a major product, and that's the one is a major standard product. You want to separate the major product from the standard product, and how do you do this? But right now, if you are in acidic conditions, both of them remain in the ether phase, right? So how do you separate this from that in ether? Adding base. So once you add base, you're making this into a charge system. So that guy will go into bottom aqueous layer, and that one still remain on top of the diethyl ether. So by doing this, you separate that your product and with the standard product. So the first step, we're going to add a strong acid to neutralize the compound, to hydrate the compound, to making the benzoic acid. But in here, you also have standard products, right? You wash it every time you wash away all the junk stuff. That's the first step. Then the second step, we're going to keep the ether layer. But when after draining off the bottom layer with containing aqueous layers, because when I end up acidic condition and the pH is still below 7, which is acidic conditions, your product and sample still remain in ether phase. So you're going to add a strong base, like sodium hydroxide solution into the ether phase, so the sodium hydroxide will neutralize with the benzoic acid and put the benzoic acid into the aqueous layer. So that right now, up to here, then your product and benzoic acid will be on the bottom layer and give you product. So now the ether only containing the standard product. Now you're going to keep the bottom layer. So when you re-acidify the bottom layer with the acid, then you will see the solid forming over there. That's the first step. So the first step of this lab, we're going to work on reaction by acid and base extraction. And second step, we're going to purify the compound even more with crystallization. So that's second step. So I'm going to talk about more in detail about second step later after you get the product from the acid and base extraction. Okay, so do you have any questions? We'll go next step. So the first step, the one thing you need to pay attention to, when add acid and that ether inside. So first you need to add some acid inside, then add the acid inside, then diethyl ether. Then you're going to use the glycerol to stir it, scratch the bottom, because the solid on the bottom is really sticky on the bottom, it's really hard to dissolve if you don't crack the bottom, if you don't use the glycerol to scratch it. So you need to use glycerol to scratch it really hard. And make sure everything dissolves. So after everything dissolves, you should see a clear solutions forming two layers. One layer that's ether, one layer is aqueous layer. Okay. Any questions? Okay, good. So let's start. And also the acid and that ether, the acid is really corrosive, so you need to wear gloves to protect yourself. So we have gloves over there, and maybe on our side over there. That's good. All right, good. Let's start.
So now we have acid here. Do we add it in here now?
You need to add that stuff. So actually you need to add some acid instead to make the cooling down. Then add the acid instead to neutralize the compound. Then that's the ether.
Oh.
Dirty. And after you do first extraction, shake it with 75 you add 75 to wash the ether again. Make sure that all the other junk stuff that we can dissolve in the layer is going to the water layer. So make sure that everything that's dissolving in the ether, the non-polar stuff. Correct.
Then you still
Correct.
Is it in there?
Right. That's still long enough to do this thing? That's long enough?
You broke it?
Nothing to do here?
A little bit.
Okay. So you have the acid ether inside?
Yes, everything's there.
And the acid? Acid?
It was acid and then the...
That's good.
Yes.
How behind? Everything good?
Yeah, we just did ice, acid, and diethyl. Now we're just scraping it.
Right, the scraping you have to make sure everything dissolves in solution. We will form the aqueous solutions. Because I said before that because the compound is really sticky on the bottom, so you have to scratch it very hard. And then because actually it will internal eventually will also dissolve in the solution. So
All
keep
of it?
all of them. They will form aqueous, they will form clear solution, form clear solution. Keep stretching. I'm going to make the use separator funnel. The one thing that we make sure that this cap is closed enough. Okay. And one thing that make sure the stopcock is closed. And when you shake it, you need to use your left hand to hold this stopcock and the right hand to hold this stop and shake like that. And always do not point this tape to student. And also, every time you shake it, you need to vent it a little bit to use the air inside. So when you shake it and vent a little bit, then you put back on the ring stand.
And that's separate?
That's separate, and you need to open the cap here, so the pressure will equalize with the atmospheric pressure. So just wait until 2 layers fall. Okay. So when we're going to draw off the top layer, so when we're going to separate the two parts, you're going to draw off the bottom layer from the bottom, and also top layer from the top, because you don't want to go cross contamination. Right? So you can do it yourself.
We did not add the water yet.
So right now you only have the first step, then you just discard the first aqueous layer, right?
Yes.
Okay, so you need to add 75 ml of water inside. Do you know why? But because you have actual amount of acid, you have actual amount of hydrochloric acid in the solution, so you want to use the actual amount of water to wash away all the acid. So 75 ml of water just wash away the amount of acid, and after that you're going to discard the water because it only contains the actual amount of acid. And after that you're going to use sodium hydroxide solutions to extract the compound into the aqueous layer. So 25 liters of sodium hydroxide and 3 times each. So you're going to combine them together in the same flask. Okay.
So we put just 75
So the first step, 75 ml of water altogether first, because you want to use actual amount of water to wash away the acid.
and then 20, and then we do 3 times of sodium hydroxide.
Yeah, so after you discarding the 75 ml of water, only containing hydrochloric acid, which is the junk stuff, right? Then you're going to create ether in here. So there are 3 times with 25 ml portion of 5% aqueous sodium hydroxide. And so total together 75. So actually what you need to do, first you add 25 ml of sodium hydroxide there and shake it when the layer is formed, and empty it and collect the 25 liters, and we add another 25 liters of new sodium hydroxide and do it again for 3 times. Do them all together.
For the water, do we use regular water or distilled water?
You need to distill water from the loose flask.
Okay. So whatever you fill